Good morning, and welcome to the second day of auth, the last one, right? Tomorrow we move into something way cooler than authentication, like the coolest thing. But today we're still doing authentication. So yesterday we talked about sessions and how they work, and today we talk about tokens. So as you walk away today, you'll have an idea of how both work, or at least have the videos and some notes about how they work, so you can make your own decision later. Okay. I realized yesterday was a lot, so take your time. Don't try to remember everything right away. Right, just practice it. All right. So tokens and how they're different. Well, this nice website, I dropped the link on Training Kit, but it's also on Slack, but it's also on Training Kit. It's called JWT, JWT, pronounced JWT.io. And what they have is this introduction link here in the middle, top there, and it talks about what they are. And if you give them your email so they can bleed your eyes with spam mail later, you could get an ebook for free. But no, just read this. That's all you need to know. It's in there. It's super simple, and it kind of gives you a little bit of the jargon behind JSON with tokens and authentication in general. So read it. But also, it's got this debugger link on the top left there. And this debugger link gives you an idea of what a JSON with tokens really is. It's nothing but a string. It's a string. It's not even encrypted. It's just encoded as base64. That's it. And there is a part of it. There are three parts. You have the headers. You can think of it as an object. Look at it right there. It's like an object. And then you have the data. So you can store data inside of a token, the same way that you store data inside of a cookie. So now you see the similarities, right? The JSON with token is just another way to transmit data between the client and the server. Again, does it have to be for authentication? Of course not. It's a general purpose thing. Just so happens that it's really convenient for authentication, okay? So a JSON with token and a cookie are ways for you to send data between the client and the server. That's it. Okay. So three parts, right? The header, the payload, where the data is, and then you have this thing called a signature. And here's the thing. When you're dealing with tokens, you don't store session information on the server anymore. Any information about the session will be stored in the token itself. So imagine now the difference between a credit card and a prepaid card. Okay, so in the case of a credit card, because you have the credit card doesn't mean, or maybe the difference between an electronic key card or a credit card and a key for lock. If you go back to the hotel to keep the same thing. About the prepaid, if you want me to finish that analogy, the idea here is a credit card will always check with the server, right? Because the card itself doesn't have any value. It's your account that is stored on the server. That's sessions. And a prepaid card, though, if the value is stored in the prepaid card, you could use it anywhere where that prepaid card works. And in theory, right, the information that it's needed, it's already on the prepaid card. But if you go back to the hotel, there's a difference between using a key card that every time you use it on a door, will check with the server to make sure that that guest is still allowed into the room, or having a regular lock with a key, with a physical key. Now that physical key is like the token now. All it's needed, it doesn't have to check with any server. There is no data somewhere that it's got to check to see if you can get in. That's a lock. And when it was created with that key, you can always, as long as you have that key, you can always open that lock. Okay? So tokens are like that. The data about the sessions is no longer on the server. So there is no destroying the session of the server to log someone out. It's a little harder than that. Okay? So that's how tokens work. Now, cookies have a 4K limit because they're not designed to store a lot of data. They're not another database, right? They're to transmit a little bit of data between the client and the server. So you can only fit 4K in there. The JSON tokens will have a higher limit. I don't remember what it is, but it could take more data because they are designed to hold more data inside. Okay. So how can we use this or how can we use JWTs for authentication? Well, the same way that we use to cookies. We're gonna prepare a JWT on the server. We're gonna put the data that used to be saved in sessions. Now we're gonna put that inside the token, any data that we need in order to process a request coming back later. Because remember, the client is gonna make another request and has to do the same thing. Before, the client automatically added, the cookie and sent the cookie on the request. Now the client is gonna send the token on the request. And you will read that token on the server, determine if the token is still good, grab the data that you need out of there. Remember, there is no database now, so you don't have to go to a database. You just can read it from the token right there. What that means is you don't need another server. You don't need another database. You produce a token, you send the data, and now the data is distributed, which means that your application can scale better. You'd have less of a point of failure now too. Because before, if you were relying on sessions and something happens to the server or database that is storing the sessions, now you have a problem. Here, you're not storing sessions anymore. In fact, hey, let me connect my iPad. In fact, the scalability story with tokens is a lot better, not only because of that, but because you're not sharing state, and that's magical. Let me show you why. Let me show you why. Hopefully this connects, no problems. I will never understand why, if I have my Zoom toolbar on a particular screen, if I connect the iPad or do anything, why would it move the bar around from where the user placed it? It's Zoom people, please. UI. So in a typical setup, let me make sure that I have my mic closer. So in a typical setup, right, you are assuming that you have a web server, a single web server. This is not related to authentication, but this is something that might be useful for you in the future as a developer, right? So you think you have a web server and your application is running on that web server, but in reality, what normally happens is and there are different names for that, but I'm gonna call it a web server farm, okay? So normally, this is what most companies will have. They have more than one web server, and here you can have one web server, you can have 2, 3, as many as your company needs to handle the traffic. Now, if you are dealing with sessions, that means that all of those web servers are also connecting to the session server here. I'm going to call it session store because we don't know whether it's a database or Redis or whatever. So let's say that this is the session store. That means that each one of those depends on the session store being where, and you can have a session store farm. You can have more than one server too for reliability. That's not what I'm saying. What I'm saying is that you have a session store and they all connect to that session store. And then when a request comes in, and even though we think that there are quite a few layers in between your client over here, okay, let's say you have a mobile phone here. Yeah, that's my impression of a mobile phone. This one is a browser, so it's wider. Okay, so we have this idea that we connect directly. This is what we think happens, right? That we connect directly to the web server. But no, there are quite a few layers in between. And one layer that could happen to be in between there, whenever you have multiple web servers like that, you probably have a layer here. And this thing is what clients connect to. we're gonna give it a name. We're gonna call it load balancer. And there could be more than one of those servers too, right? So what happens is really that the load balancer is the one that communicates with all of the servers in the farm, okay? And it has an idea. There are different workflows for this, but it's got an idea of how busy each one of those web servers is. You know, there are different ways. One way is it continuously ping them and see the response time, or it works in different ways. But the point is that the load balancing layer here, they know which of those servers could answer a potential new request faster. So what they do is they take all of the requests and then they route those requests to the web server that would. It's like you managing a set of, like, imagine that you're managing a set of workers, and some new work comes in, and you look at all the workers and you're like, oh, I see Luis has more time on their calendar to be able to finish this faster, right? So that supervisor is looking at everybody's calendar and say, okay, if I want this job done quickly, I'm going to find someone that has a slot to be able to do it. Because if a worker's work is busy for the rest of the week, there's no point on giving that work a new work, right? So load balancers do something like that. It manages the load, right? So when you're working with sessions, you have this dependency on the session store. But when you are working with tokens, though, and you sever that dependency, now, whenever a request comes in, since it doesn't have to check nothing, any one of those web servers on the farm could potentially answer that. But it's even better than that. You could take that request. This is gonna be a little far out, but you could have another farm somewhere, and you could have a request that comes into, let's say that there's a client here that makes a request to a load balancer, and you can even send it to another place. Like, you could forward a request that includes a token without any problems, because any one of those web services can, as long as they share the same secret to looking into the token, they can handle the token, and they don't even need to be connected to anything. There's no sessions, there's no database, there's nothing, right? All you need to have is a standalone web server that knows the secret to be able to look at the inside of the token and get the data out. So for scalability, to be able to just spread and have multiple servers, and to take a token and be able to forward it, it's a lot easier using tokens than it is using sessions, for sure. So there is power in this. A lot of companies have moved to using tokens for things like authentication, even though they may use cookies for tracking you or saving other things, preferences and stuff like that. Okay. Questions about this non-authentication related? Dribble. So let's go back to today. So now we know that a token is just a string and it's got 3 parts. So how do we create one? Well, also on this same website, there is an area here that says libraries. And on the filter here on the right, you could pick your technology. In our case would be Node, and you'll see that we have 2 libraries for this. For Node.js, we're gonna grab this one, JSON token. JSON token is created by the same people that created this website. It's a company that sells security as a service. So this is the command that I'm about to run. So you can run it too on your guided project. It's gonna do npm install JSON with token. Right, now that we have it, this library, same as bcrypt.js. Remember how bcrypt.js will let you verify when the request comes in, and you could check to see if someone is, everything is good with the session. This library is gonna let you produce a token. You will manually send the token. The client, remember how yesterday everything happened automatically? Well, not anymore. You might remember from the front end time when you were doing React that you learn how to take that token from the response from the server and store it in local host and local storage or somewhere. Depending on whether you're doing it manually or you're doing using services from another company, that may be something that is already taken care for you. But if you have to do it manually, you just pick a way to store that token on the client. Even though we're gonna show you JSON with tokens, and that's in the context of having both identity information and also the access information about access. Is not always the case. Most of the time, and there are other technologies for authentication and authorization, most of the time you have at least two tokens. Okay, at least. One is the access token, which is the one that the API is going to check when you try to access a resource. That's the access token that tells the server, this is the stuff that I can do, or the stuff that you told me I can do. Okay. But then the other token would be, and you can combine identity and access together, right? But the other token would be something called a refresh token. And the refresh token is a way for you to get a new access token, okay? Because you don't have sessions and you cannot log out someone, force log out someone easily when using tokens. That means that I'm gonna give you a token and I'm gonna trust it when it comes in. Remember, the token is like a key now, physical key. The lock will always trust that key. So how can you solve the problem of what if I want to, I gave someone a key and then I don't want it to come into the room anymore or into the house anymore? You replace the lock. It's not as simple as just invalidating the key anymore, right? Like happens on a hotel. So this library, it's going to let you produce a token, but if you want to have refresh tokens and any other mechanism, or if you want to separate identity from access from the refresh tokens, you have to do that manually. This is work that you have to write code for. Not hard, well, not easy either, but it's not super hard. It's the same process. It's just now you have to check for more than one token when the request comes in. Okay. Let's see how to do it, right? The first thing would be, okay, how does that work? What does the server have to do? And then we go from there. So let's talk about the server. We just said that the server has, of course, verifies the credentials and all that stuff. But once you know that someone is good and they logged in correctly, you have to produce the token the same way that we produced yesterday, right? We saved the session and produced a cookie. So now you have to produce a token. Only that there is no session. We're not saving anything anywhere. And then that means that the data that you need, the data that you would, when the request comes in with a token later, the data that you would need to handle that request has to be inside the token, right? So I needed data to the token, and then it's got to send the token back to the client. Okay. Now, when a request comes in later, a new request comes in to a restricted area, you have to validate the token. So the third part of the token here, when we look at the debugger, we said that we have the header, some data, and then we have this signature. So creating a token, we're gonna refer that to signing a token. So we're gonna sign it with some secret that only the server knows. And the idea here, since all the data is available on the client too, because when you send the token back, any client can open and see that data. What if they want to modify that data? What if they want to give themselves access to be an admin? Well, that would change the signature, because the signature is a combination of encoding the header, encoding the body, and then adding that secret in there. And then all of that is encoded. So any small change, any change at all that you do to the data in the token will invalidate it. So the signature guarantees that the client did not modify the token in any way. That's where that's what we trust as the security model for the tokens. This is how we know that when the server produces a token and says that you are from sales, you're not going to go in there and change that to say that you're an admin on the system. You can't do that. I mean, you wouldn't do it, but an attacker that may steal the token cannot change the privileges inside of that token, for instance. They cannot change your ID if the token has the let's say the client ID, the user ID, or the employee ID. So none of the data on the token can be changed, because if anything is changed on the client, it will invalidate the signature. That's where the security lies. Okay. So when we say validate, or we could say verify too, let's say verify. Verify that the token is valid, right? And then if there is any data that the rest of the application needs in order to provide access, remember yesterday we just added a flag in there to say that the user is logged in, but you could have other data that you need, maybe the role of the user to see what can they do to do a little bit of authorization. Then it could, look into the token and make the payload, and this is just a fancy word for data, available for the rest of the API. Okay? And you can see that happening in a piece of middleware that we write for that. Questions about the role of the server and all this? Okay, there's a little more work for sure than it was. By the way, there are libraries to deal with tokens too, but we're gonna go raw on this. It's important to understand the process. What about the client? What does the client have to do? Well, because the client before didn't have to do anything. Now the client has to actually store the token, and it has to send the token on following requests, or at least those requests that will need authentication. Okay. And since we don't have any logout functionality on the server anymore, the client has to destroy the token on logout. Now we're trusting that they're going to destroy the token. Can we have something in place so that the server can invalidate tokens? Yes. Just store any tokens that you produce and send, just store them somewhere in a database. At that point, though, now you are kind of duplicating the use of sessions, at least for the logout functionality. And that also means that on every request, when you check that the token is valid, then you read the data, and then you go and check in your database to make sure that that token has not been invalidated. Okay. If you don't do that, keeping either a black list of tokens that you invalidated or a white list of tokens that are still good, that means that you will always trust the token. And as long as the token is still valid, meaning it hasn't expired, meaning the signature is good, then you will trust that token to be good. And that's where the refresh token part comes in, right? If that's your identity and access token, you may say, if I am a high security place where it's important for the security of the data, that if someone needs to be revoked privileges, we don't want to wait too long to do that. With tokens, what you would do is you give them like a 10-minute token or something like that. But then you give them a 1-day refresh token. So what happens is when they send every request, they send both tokens, and then you check the access token. If it's not good anymore, it expires because it only lasts 10 minutes or 15 minutes or half an hour. Then you look at the other token and say, okay, let me check the refresh. And then the refresh has probably the same information that you had on a cookie, like the ID of the user or something like it. And then you take that and you go and check the database and say, is this user still good? If they are, you produce a brand new access token that will last another 15 minutes or half an hour, and then provide access and then send back that new access token. So there is work that have to be done that is extra there when handling refresh tokens at the same time. Questions? I definitely want to write some code. Okay, so let's go look at the auth router here. And we have this, I don't know if I want to do this on register. Let's do it on login. We just need to register a user to have it. And you can also produce the same thing on register, but let's do it on login so that we can repeat the process, login a few times without having to register a new user. So what's a good line here where I can start working on the things that the server needs to do? Let's have that on the right there. So the server needs to produce a token. Where should I be doing that on the auth route? What do you think? Pick a line here. A good line for that. Before line 42, so line 41.5, right here. Boom, here we're gonna produce a token, const a token. That would be const. Oh, come on. Okay, token is equal to, and then we just sign a token, or get token, or make token, or generate make token, or make job. So we're gonna have a function in here, right? So let's call it make job. And this function, since we already have the user, we might as well just give it the user to save some information about the user so that you see it, okay? So that's gonna give me a token. Oh, wait a minute, I need that function, so let's go write it. All right. And this is gonna take a user, and it's gonna give me back a token for that user. Great. So how do I make that token? I'm gonna return. Oh, wait a minute, I need the library. Oh, let me go up here. I'm bringing the library. So let's call it JWT. Is JSON web token. We did add it, right? I think we did. We'll see. We'll see in a minute whether we added it or not. Still not breaking, so we're good. So we bring in the library. Let me add a comment here. Install the library. Don't forget. And then down here in our function, we're gonna use it. Let me close this thing. We're gonna use it to make a job. So what do we return? Well, we're gonna return a call to JWT, and JWT has a sign method, okay? And that sign method is gonna need some information like, okay, give me the data, you're gonna need some things that you need to pass it. So the first thing is the data, right? Give me the data. What is the data that you wanna store in the token? And I'm gonna call this payload just to stay with the jargon. And then after that, it's gonna ask you, all right, I need to sign this token in such a way that no one else can modify it and re-sign it. So I need a secret. I need something that only me as a server knows to kind of guarantee that that token is, nobody else can sign it and produce a valid token on my name. So we need a secret. So we're gonna have this secret here. And then we need to set up options for this. Options like when does it expire? So let's create a payload, const payload. I'm gonna make this be an object. It's gonna get merged into the payload of the token. Let me show you something real quick so that you see what I'm doing. You see this sub over here in the payload data? See this ALG here on the header and the TYP? Those are called claims. And the JSON web token kind of specification defines a set of claims, but then you can add other things, like in this case, they're adding the name, okay? So this IAT is when the token was created. This is just JavaScript date, when it was issued, okay? So the library that we're using provides longer names for some of those. JSON web token. Here we are. It provides options for things like it. Like for instance, the ID of the token or the subject. And the subject is normally, if you're using this for authentication, it will probably be the user ID. This is who is the token about? What is this token about? What is this token saving data for? And then you have headers and stuff like that. So we're going to use this subject key just to have the user ID be the subject of the token. So subject. That's going to translate into the sub claim, right? Subject. And we're going to make that be the user ID. Maybe the username be the username on the user. I think that's, did we have a role? I think we did have a role, right? So let's save that. The role is going to be the user.role. Okay, so that's the payload. That's data that is being saved inside of the token now. And then we need this secret thing. So const secret, it's going to be equal to, and of course, process.env.jot secret, because we want to change that on the, when we go to the server. And if not, you know, just I'm going to have it in here. Just the default value. And then for the options, at least we want to say when will it expire. So I'm going to use the expires in. And I'm not coming up with those options, right? They are here. If you go check out the options here, there's going to be expires in. There we go. You know, there are also, look, it says there are no default values for this, not before, audience, and all that stuff. You have to provide them if you wanna add them. So the expires in is gonna be a key on the options object, and you could pass it values like 1 hour, 3 hours, milliseconds if you want to, but you could say like, look, like 1 hour, like that. Let's do that. So 1 hour. Here we go. I did not ask, is it better like that? Because I think the font was too small. So that is it. Now you're solving the first problem, which is I need to produce a token, add the needed data to the token, and now we need to send the token back as part of the response. Great. Super simple. We can do that. So we have a token now. It's right here. All we need to do is send it back. So we're going to say, hey, comma, token. Boom. So when someone logs in, now they're going to get that token back. Let's go try this out by registering a user. Make sure that we have a list of empty users. Yeah, there are no users. Going to the register. I'm going to make user 1. Send that. And then user 2 is going to have a role. And the role is root. There you go. Let's call it admin. It's cooler. So user number 2 is the admin. Send that. Okay. Oh, role is name values. Ah, I didn't like that. Oh, great. So that means that, oh, maybe I don't have any roles defined. So what happens if I do that? It should give me an error, right? We don't have any roles. Yeah, we don't have any roles. So we need to save some roles. Okay. But I don't want to create an endpoint for that yet. What can I do if I wanted to just, you know, add some roles into my database without having to create an endpoint? Something real quick just to test, like one role, that's it. Well, I could use SQLite Studio for sure, right? Migration is not about data. Migration would be about the structure, but I could seed some data. So let's look. Oh, look, there's a seeds folder here. I wonder what's there. Let's see in it. Ah, look, it's adding some roles. It's just doing an insert. me see that. Let me see if that works. So let's say we might even have, do we have any, no, we only have rows. That's great. So I'm going to do this. I'm going to say connects, seed, run. Let's see if those seeds are good. Oh, look at that. It said that it's seeded. So we should potentially have some rows now in the database. So the command that I ran, if you go watch the seed video, is connects seed colon run. And that will run any seed files that we have here. Turns out that this project has a seed that saves admin as the ID 1 and user as the ID 2. Okay, so let's try making this user 1 by passing it the role ID of 1. Is it role? Is it role ID? I don't know. Let's look at the migrations. Is it role? Roles that is role, just roles. Oh, excellent. So let's go try it out. Hit send, and there you go. So now the user 1 doesn't have any roles, but the user 2 has the role of admin. So we know that user 2 is our admin. Let's go make sure that we can get the list of users. There they are. We have 1. Hey, where's my user? Where's my user 1? Did I get an error when I try to insert 1? Okay, okay, great. Let's make 1 be a user. Maybe I did get an error I didn't notice. Let's see. Oh, there you go. Yeah, there was a problem there when inserting. Okay, probably the foreign key. Now we have 2 users, and we know that user 2 is the admin. Yeah, user 2 is the admin. Great. So let's try the login, and let's log in as 1. Hit send, and we get back, hey, welcome to our API, and then we get this token. Excellent. We are now sending the token back. That will be our 3rd requirement. I mean 4th. Okay, so produce the token, add the data, send the token, and now we need to, that will be the 3rd requirement, right? So now we need to check how to validate the token whenever a request comes into the API. So let's look at the content of the token. And this is going to be very scary if you've never seen me do this before. If you didn't watch the video, I'm going to take the token that we just got, and I'm going to place it on this website, and look at that. See that? Subject is the ID 2, and the username is 1. And even the role shows up there. That means any data that you store in the token, of course, you can encrypt it so that it's not visible like that. But the point is, encryption can be broken. So even if you do encrypt the data, still the data is on the client's hand, and they can offline work on decrypting it. The point being, just add as much data as you need to process the requests. Don't add any extra information in the token. It's not meant to do that. It's meant to, as a temporary space where you store data that you know you're going to be needing when a new request comes, like the role, right? Maybe you don't want to check the database for the role every time. So you might as well just store the ID of the role in there. Cool. All right. Questions first about the process of producing the token, adding data to it, and sending it as part of the response. Those 3. All right, so go ahead and implement it. I'm going to show you the code now. This time I'm going to have you write it instead of just pasting it there. And you will need the make job function. So I'm going to break this into 2 so that we can show you both the top of the file where we bring in the library, and then the bottom of the file where you have the make job. Should give you all the code. Go. Remember, you will need to register a user or 2 and you will need to run this. Let me see, let me give you the command for the seats. How are we doing? Any any errors? All right, so can we continue to the next section? Yeah, good question. So what if I wanted the user to be just logged in right after they register? The same thing. What you would do is produce a token as part of the registration process too. So all you're doing when you add the user here, okay, and then the user comes back, you just return into a one. So before here, you produce the token. Where's my code? Where's my login code? Here we go. So you would produce it because logging in means they have a valid token. So you produce a token here, and then when you send back the data, you not only send the user, but you probably want to send the token back too, like so. And now the user, the client that is using your API can grab that token and store it and do their part. Okay, anything else? All right. So let's take a 5-minute break. And then when we come back, let's move into the second part of that, right? Which is what do I do when a request comes in and I want to restrict an area? I want to check into the token to make sure the token is valid. So I'll see you in 5. And we're back. So will we be covering refresh tokens? No, unfortunately not. Research there for you. Is it secure to store the token in local storage? Depends on who you ask. There are a myriad of articles even saying that you shouldn't even use JSON web tokens for authentication. I don't think there is an agreement about something that is secure. I don't think there is such a thing as a fully secure. Um, if you ask me, I think having it in memory is safer. And then you store the refresh token. Since the refresh token doesn't really have anything other than maybe the ID of the user so that you can then go and make sure that the user still have access, that's probably safer to have on local storage or maybe inside of a cookie. You can even have it inside the cookie. That's just a header. Uh, but then the token itself, the access token itself would be in memory. Memory is probably the safest that you can have because each application has its own memory space and no one can grab it unless they are actually running your app. So yeah, it's always dangerous. So my advice would be don't try to understand too much about this and feeling like you want to do that. No. You use a library that use a server that has components that take care of all that minutia for you. Okay. Any more questions? Security is hard. Please don't try to do it yourself, please. I wouldn't, for sure. Okay. So we're still missing a part, right? We need to check when a request comes in. We're gonna work on this. Let's say that request comes into a restricted area. In our case, would be the list of users. I want to verify that that signature is good, that the token is still good. And then if I have any data that I care about, I could take that data and put it somewhere so that the rest of the API can use it. Okay. So good place. What do you think is a good place to go and implement the code to check for the token? Let's look at the server first. We have the list of users. Okay. Let's look at the user router. Oh, look, there's a service, a router, and all that. Okay, there is this restricted middleware, and it's being used for this endpoint. Okay. Maybe we can use it for all of the endpoints here. Maybe I could say router dot use and always use restricted instead of having it local just for this endpoint. What do you think? It's a good idea. So now if I have any other endpoints in there, it will apply to all of the endpoints if I wanted to. Or you could have it just for a single endpoint. Okay. Thank you, Brian. Good. Okay. So that means that this restricted middleware is the one in charge of blocking access to my user's endpoint. It's obviously not doing that now because we can still see the users. Okay, so let's go take care of that. Open the restricted middleware here. Oh yeah, it's only calling next, so we should probably add some code in here to verify that users are logged in. So what do we need to do? You can tell me what I need to do. What did we say we needed to do on the server for that? No idea? Help me out, please. Please. What would be step one? Yeah, we want to check that we have that token, right? And if we have a token, go next, else, you know, status, but code-wise, I don't know. Yeah, of course, we don't know yet. None of us do. We're gonna go and read the documentation. No, but yes, that is it. We have to check. Well, we should definitely check if we have a token, right? So we need to try and read the token from somewhere. Token is gonna be coming from the rec dot headers dot, yeah, authorization. This is a little more realistic than having the password there. This is normally the go-to header where the token is going to be placed. So we're not going to be reading passwords for there. We're going to be reading tokens from there. So in reg.headers.authorization, there should be a token. We could check for that. We could say if we have a token, right? And then else, something else would happen. Okay, let's get rid of this next, put it in there. So if we don't have a token, res that, we're going to ask him to give us one. Res that status 401. And then we're going to do a 401 and then send back a message. Okay. Excellent. So we have a message. If you don't have a token, what happens if you do? Well, the next step is it valid? Well, we need to verify the signature, but we're not going to do that manually. We're going to use the library. So we need that library. Let's go get it. Don't we already have it? Let's just copy that. Where's my, I could just type that, right? The auth router. Copy in here. Laziness. Work more. So now that we have the library, we can use the which method? Can someone real quick go check out the name of the method that we can use to verify the token? Verify. Funny. So verify, right? And then we need to pass it. What is it that you're verifying? A token. So I'm going to give it a token. But then it needs the same secret. So we need a secret for that. Okay. And then the third argument would be, and you can have some options that you pass it, but you normally don't need them. The third thing is what happens after that process is done. So we're going to have a callback function in here that may run into an error if the token is bad, or could give you back the decoded token if everything is good with the token. So we're going to check, do we have an error? And that means something wrong with the token. Okay. Else, token is good. We can see the data. Okay. The data is going to be inside it is decoded inside decoded token. So what happens if something is wrong with the token? Hey, whatever, it expired, someone tried to modify it on the client. We don't care what happened. The point is that you have no access. So if you're there, I'm going to give you a message. Okay. And yeah, it sounds like a tool that we could use to put nails inside of wood. So token is good. So what can we do with it? Well, if we wanted to have access to that, we could just save it somewhere, like in the response. Maybe we could say rec.jot equals the decoded token. Boom. Now, any middleware or endpoint that comes after this restricted middleware will have access to rec.jot, and we can see the data inside there and make decisions about it. So we're going to keep it there. And then we're going to send back a response saying, hey, you're good. And it's going to be a 200.json. And then just send the message with, we're good, right? Are we going to do that? What do we do here in this middleware? Produce a response, right? And then we send back a message that says, All good. Cool. Seems like cookies is a lot simpler. Oh yeah. It is. It's also less scalable and has problems with mobile clients, but it's definitely simpler. You can't really forward cookies to another. Yeah. I'm not saying that I prefer tokens, but I do, even if it's a little bit more work. So does this look good to you? That's the question. Like, look at this. Don't think that I'm doing the right thing. Just look for something that is off on this middleware. It's here. Okay, where do I put that next? Yes, we need the secret. Okay, over here. With that, is that good? Now we have next in there. And we also need this secret, okay? So let's have the secret up here. Const secret equals to, oof, you know what's about to happen, right? You know what's about to happen. I'm gonna have to go and, yeah. Now we need to copy this because we have to use the same secret. Why am I doing this? Because normally you don't have to. You can just provide access. But normally we put information inside the token because we need it later, like maybe the user role, maybe the user ID, maybe the username. So this decoded token is what you get back after the library opens the token, so you have access to the data that you saved in there. If you don't need any data, you just don't save any data inside the token, you just produce an empty token, and then you wouldn't need to do this. But imagine that later I want to check for the role before I let someone come into an endpoint. Then I need to see that data. Because remember, you're not going to the database, you're trusting the token there implicitly. You're going to rely on the data that we have inside the token. All right. Anything else? Now we have we have this problem that we're duplicating this stuff. We can fix that in a minute, but what else can you see here that it's kind of a little off? Let's try it. Let's try it out. So we're gonna log in. Okay, we got a token. I'm gonna copy this token because we need to send that token as part of the header, right? So if we go here, we should get you shall not pass. We don't have the header. So let's add the header, the authorization header, and make that be the token. We're gonna send it and all good. But that's not what I wanted. I'm trying to get to the list of users. Why am I getting this all good? That's right. This is now returning from the middleware. That's not what we want. So how can I fix it? We can remove it for sure. Yeah, we don't need that. Our middleware should be, okay, everything is good. Just go ahead. Keep going to wherever you were going. We were going to these users endpoints. When we hit send now, we get the list of users. That's what we wanted. Now, let's see how this is working, okay? our users router has the restricted middleware being applied. So on a request, when the request comes in, we're going to read from the header, from the authorization header, we're going to read the token. Okay, we need the secret so that we can decode it. And then we check, do we have a token? If not, then we're going to say, hey, you need to give me some, we're going to give a photo one. You're not logged in and you don't have any good credentials. If we do have a token, then we're going to verify it to make sure it's still good, that no one tampered with the token or that the token has not expired, okay? So the way that the verify method works is we give it the token, we give it the same secret that we use to encrypt or to sign that token, not encrypt it, sign it, to sign the token. And then a third callback function here that if there is any problem, it's going to just have an error value here. So we check for that. If there is an error, something wrong with the token, then you're bounced, okay? Else, then we just call next. And if we need the data that we have inside the token, then we can add it to the request so that endpoints or anybody else that executes after this middleware could read that data from write.jwt. In fact, I could go to the users here, the users router, since this runs after the restricted, and I could send back the users, or I could send back an object that says, you know, the data is this, and also I want to take a look at the JWT, just to see what's in there, right? .jwt. So we send that. We're going to have this data property there, and also here's the information that we have inside of the token. It's got the expiration, like when it was issued, when it expires, the role that we saved in there, the username, and the subject that was number, the ID of the user. So we can see, we can save data in the JWT, and then we can see it later when it comes back. Cool. All right. This time though, I'm just gonna give you the code for the restricted middleware because it's nothing particularly interesting there. So go ahead, inside of the restricted middleware, make sure that you add this and test it out. So you will log in, get the token on the login, copy it without the quotes, and then when you go to /API/users, just make sure that you add the token as the authorization header, and then just add the value in here without the quotes. And it should work. It should give you back your data. All good? Can we continue to the next step? Questions, errors? No? Good? All right. I'm gonna need help now. I'm gonna make sure that you can unmute because it's a little harder than just typing it on Slack. So here's what I want. I want to see the role for the user as part of this response. So when I go to /API/users, I would like to see the role there. Can someone help me do that? Where do I go? Okay, you can speak to me. Don't worry. Don't talk to me. Come on, be my navigator. I'll be ears and hands, and you're gonna be the brains and the mouth and the eyes. So I want to see when I get the data. I want to see when I see the role as part of the information for the user. So someone said the user model. Okay, let's go look at the user model. What do I change for this? I want to see the role. Line 11, add the role in here. Okay, like so. Let's save it. Okay, let's go in there. Great, we're getting the role. That's not what I want though. I want the actual role name. So if this one is admin, I want to see admin. What can I do now? But we're making progress. I just want this to be. Yeah.
We will have to do an if statement before we send the data.
Okay, where would I do that? So what if we have 25 roles? So we're gonna have an if statement that says, if one is this, if two is that, if three, if that. And what if the IDs on the database change? Because whatever. Mhm. So I have a table in the database that has the roles. And I have a table in the database that has the users. And the user has a foreign key that points to the role. So the user only saves the role ID, but then again, the roles table has the name of the role. So how can I get that data to include the actual role name?
Oh, you can join tables.
I could join tables. Yes. Okay. So how do I do that? Sounds like a join. Yes, it does. Who's going to help me join that? I'm going to get us started. I'm going to say, I want DB users as you. Join roles as R. What else do I need?
You need to, right there, you need to connect the foreign key and the primary key. So, so this will be u dot role ID probably.
It's called role, but yes.
Okay. And then r dot ID.
Okay, so we have the join. We're joining the foreign key on roles to the primary key on the roles table. Okay. And then we're going to select, probably want to see the user that ID and the user that username. But then from the roles, though, what I really want to have is r dot name. And then we're going to organize this by the user ID. Save that, and that's what it looks like. Want to get information from the users, join it with the roles using the role foreign key pointing to the referencing the ID on the roles table. And I want to see the ID and the username for the user and then the name from the role. And I'm going to give this a name. Instead of name, I'm going to say as role. And then save that. And let's go try it out and see where we are. Ah, this is looking good. Now we have the admin. So that means that if we only have the username here, that role is still role 2, okay? So that's not what we want. We want to have admin in here, okay? So how can I change that data? This data over here. Where do I go now? Well, I would probably go to where I'm doing that. So let's look at the auth router. Where am I saving the data on the payload? Right here, over here, okay? And then we have this user. And we're grabbing the role from the user object. Only that the role that we get in there is still the ID. Why? Because where do we get that user from? We get it from a different method. We get it from the find by, right? So what would I need to do if I would like to have access to the role that we get back from the find by, having the actual role name instead of the number? What can I do for that? Probably go to the user model.
Do we need to join that table in the find by as well?
Probably do, right? Because we have the data on the find, we just don't have it on the find by. And this is just sending the users. And we could still filter that, right? So we're gonna make some changes. We're gonna grab this, not the select, and we're gonna bring in that join in there. So let's do that. Bring in the join. Don't be afraid. It's just a simple join. Okay, users are you, and now we still get the users back, and then we're gonna filter this, and this filter that's coming in is filtering on the ID, I think it is, right? For this. If you don't remember, we're passing only a filter that looks like this, ID. So that's what the filter is. So if we know that that's what the filter is, we could say where the that ID, so we want to filter that on the user ID, is equal to the filter that ID.
It might be filtering by username.
Is it? It might be username in this case. That's right. That's right. Yes. This one is by username. I totally forgot about that. So what do we do? So we have the username in there. Well, let's see. And then order by the user ID. And we need to select data now. It's going to be a little different because we also want the password there. So we're going to pass in the user that password. We need it for this case. The ID, the username, the name as the role, and then we also want the password there. Let's see where we are. Then we go from there. Where are we? We have the data. Now we need to bring it in. Let's see. The auth router here. And let's see, it's not user role. It shouldn't be that now. So let's see what we get back. Passing the username. Yeah, you're right. Let's see what we get from the database. if we changed the user model here, yeah. So we're sending ID, username, role, and the password. Okay, we should be getting all that. Let's try it. Let's see. Am I not hitting the right thing? Oh, ha 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 ha, login. Okay. I'm passing the wrong token. So, boop, 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 boop. I was hitting the old endpoint. I mean, I was still hitting the user's endpoint. I wasn't logging in. I didn't log in yet. So that's what I wanted to see, right? So we have that data now, the way that we want it. We want to see the actual role. So now, why does it work without any hiccups, even if you're using this filter? Well, because the username only exists in the user table. It's not on the role table. Okay, so we can continue to use this code without any hiccups. All we have to do is do the join there. Okay. Why did I need to log in again? Why did I need to log in again in order to see the role? Any ideas?
Because you had the old JWT on the header.
Oh, uh-huh. So?
And the old JWT had encoded the old just role number instead of the role name from the join.
Yeah. So this is an example of where you trust the token implicitly with the data that it's got, but you're not going to the database to see whether that query changed or not. So you only ran that query when you logged in and produced the token. After that, when the data comes in, it's always going to be statically, remember that the key, the prepaid card, the data is static in there now. It's not going to change automatically. So if you want to see the new data that you're producing, you have to actually generate a new token that has that new data. Okay, great. So now that we have, well, what time is it? Yeah, when we come back, we're going to do that. So now that we have, as part of our data, and of course, it's going to be part of the JSON web token now, we have the actual role. What if I could do this? And let's go to the server. This week is about authentication, but let's do a little bit of role-based authorization. What if I could do this? What I could have some kind of middleware there, and I could just go to the users and say, check role admin, and say you have to be an admin if you want to see the users. How can we implement that? I'll tell you, super easy. I'll tell you in 5 minutes when we come back for the break. See you in 5. Yeah, probably a good idea to start the timer. And we are back. Questions so far? Anybody want to take a stab? Helping me implement this middleware. Let's create a file here. Come on. It's gonna help me out. Gonna get it started. Module.exports. Definitely middleware function, so reg rest next. Boom, done. Let's bring it in. I think I have to step out. Let's try it out. Aha. What did you break, Luis? Next is not a function. Next. Right, rest next. What? Where is this happening? Line 2. What? What's going on? This is a misleading error though. That's not what's really going on. Who's gonna help me implement it? Come on. At least help me solve this error. This is not correct, but it's gonna be a little harder. But yeah, maybe you know what it is.
I think you could do two different ways to go about it, and I'm not sure which one is the right one. But you could query the database with the provided ID, or you could trust the web token and query the database with the one provided from the web token.
Yeah, we're gonna trust the token. in this case. This is why we went through all the trouble just to make sure that the role was already in the token. So we're gonna trust that. But the problem is that I have this next is not a function here. For some reason, when I added this middleware here, it broke my application. And this is definitely a middleware function, right?
I think you need to pass in line 16 on server.js after admin, comma next as well.
Here?
Inside the parentheses or check row.
Here?
Yeah.
I can't do that really. Because that would mean a function that takes, I don't have any next, so I have no next to pass. Good try, but do I have to import something? I don't know. All we needed was to import this middleware. We're good there. We have whatever we needed to import.
Is it passing you an error because you're passing an admin into check role? You're not doing anything with it?
Yeah, I am not doing anything with it, but I am just calling next. So there's something going on here that for some reason, this is breaking it, right? If I take that out, that's what the problem is. You'll see if we could hit that endpoint of problems. Okay, we're good to go. But as soon as I do that, then it breaks.
Is it trying to execute next? Admin, sorry.
It's executing the check role. So my question would be, what goes here? What can I use there?
Oh,
Should be middleware, right? So if I do this, let's do this. It's simpler. Console.log check role. Okay, and then I pass it this. What do you think the console would be? What do I get when I execute check role?
do you get a callback?
Why would I? Well, what makes you think I could get a callback? Like by looking at the code. So I am importing check role by importing this, which is a function. Obviously, it looks like a middleware function, right? So what happens if I execute it? What do I get back? What do I get back when I execute any function?
Whatever you return.
What am I returning from this function?
Undefined.
Undefined. Okay. And can I pass undefined as middleware?
Do we need an anonymous function to avoid that? Like, because we're not supposed to call it ourselves or something?
Good question. Okay. But we know what the error is now. The error is that when we execute the check role, what we get back is undefined because there's no return value here at all. So we're getting back undefined, and we cannot pass undefined. What I need is a function that returns middleware. So you're correct. So instead of having this function be like this actually should be a function that takes a role. Okay. And then, and you could even wrap that other function in there and then just say, okay, I'm going to get a role. And when I get a role, I'm going to return something else. I'm going to return this function over here. I find that to be confusing. So I'm gonna go the easy way and do this just because I get confused. It just looks confusing to me. And then I'm going to return that function. Okay. And I really like the word function. I'm sorry. Bear with me. I like functions more than arrow functions. But you could just return an arrow function there. It's the same thing. Okay. So now my outer function is going to accept a role. So check role middleware is not really middleware. It's a function that accepts a role and returns middleware. That shouldn't break now. I hope. Okay, doesn't break. That's progress, right? It doesn't break. It's not doing anything, but it doesn't break. But the point is, whenever you see middleware like helmet or express.json, that means, or course, that means that the helmet function per se is not middleware. It's not written as rect next. It is a function that returns middleware, returns a middleware function. Now in here though, because of scoping and closures, I have access to the role and next and rec and res and all that good stuff, because role is part of the outer scope. So I could say if, you know, the role is equal to, and where would I get access to the role of the logged in user? Or at least I want to say, you know, if the role that I have on the token coming in is the same role that we are looking for. Where would that be? Where would that role? How can I get access to it? Let's look here on the left. Let's look at the auth router real quick. Oh, no, actually, we're not doing that there. We're doing that. Well, yeah, let's look at it there to see the beginning. What do we do there on the login? And we did save the role, right? And then after that, the next step would be the restrict the middleware, right? So is there anywhere where I can get access to the role that was on the token originally?
The decoded token in rec.jwt.
All right, so I could say rec.jwt dot what?
Was it the role?
The role. Okay. So if that's the case, they match. If not, I'm gonna do the else right away. If they don't match, so if they match, you're good to go. If they don't match, we're gonna bounce that request. Status. This time though, you are logged in, you have a valid token. The problem is that you're not authorized to see this. So instead of giving you a 401 that we normally use for you're not logged in, I'm gonna give you a forbidden. And this means I know who you are, you're just forbidden from accessing this. You have no right to access this. So, and then we send back a friendly message like, okay, save that. So we just wrote a function that will take an argument and return middleware. And then inside of that function, we use the argument value that we add from the outer function, and then we're checking against the JWT. We have to rearrange some things now. I'm gonna go back to the user's router. And I'm gonna grab this out of here. I'm gonna put it on the server instead. Okay. And then, because if we leave the check role first, this is going to run before the restricted middleware runs. We can't have that happen, right? So restricted, let me show you. I'm going to put it top and bottom here. So you could go, the way that the code executes is top bottom. So read it that way. Like that, right? We want we are relying on having the JWT on the request. And the JWT gets placed on the request on the restricted middleware. So the execution order should be first, when you hit the endpoint, first, I want to check that you're logged in by running the restricted. If you're good to go, that means that the JWT is going to be placed on the request for you. And then I could run the check role middleware, right? That will only run if you have a token and we were able to place it on the request. And then I could rely on that role being there inside of that token. So this is why I can't have, a check roll out here and then have the restricted inside of the router. That wouldn't work. It would break. So instead, I'm going to say, first, I'm going to check restricted here. And then if you pass that test, I'm going to have that JWT on the request, and then I could check for that JWT on the next one. If you don't have a good token, then you're going to get bounced from here. This never executes. And if you want to get all the way to the router now, you have to be logged in and have the right role before you hit the router. Questions? And then inside of the user's router, we removed that, and we can get rid of this line now because we're not running the restricted middleware inside of the user's router anymore. Questions? Does it work? I don't know. So let's go and log in with OnePass and copy that token. Then use that token here. Hit send, and you have no power here. Why is that? Well, because user one has no power there. It's a user, not an admin. So let's duplicate this and then log in here with user two. We remember that user two has the admin role, so we're going to send that and grab this token now. Let's duplicate that so we can have both tokens and have this next to the login. And in the headers, we're going to provide a token that was given to someone that was actually an admin. Hit send, and now we have the data. So again, this user here logged in with someone that was not an admin. This token, though, that we got is from someone that logged in as an admin. And now we can see the list of users. This is super basic role-based authentication, where you can specify with your endpoints which role you're using to restrict it. This can go really, really complex. You can have access levels and all that stuff. If you are going that way, there are different ways of approaching it. A popular one is to use the columns to separate when you're adding your claims. So you would have things like role admin and have other things, and then you need to parse that. And there's a whole world out there. I don't think there is a solution that everybody accepts, but if you look into something called OAuth, it defines some guidelines for that. So OAuth, I want to leave you with this spec. The latest version is OAuth 2. Solve some problems. You want to work with this one? Oh, look, get the white paper. Yeah, no, I'm not giving you my email. Sorry. I'm just gonna, yeah. So this is the name of the RFC, the 6749, and this is the authorization framework. I want to give you some caution. The RFC that defines the OAuth specification gives you very, very little. So normally companies that use that, they will also combine that with other RFCs, with other I'm not going to say framework, but standard specs. Okay. So Auth2 by default is not enough. You're always going to have some other stuff in there. Oh, look at that. Map of Auth2 specs. Okay, let's see. Maybe this is interesting. Okay, here, yeah, the core spec. And then you have how to handle a better token usage. There you go. That's another spec. Oh, this one is about the model and security considerations. That's another one. And if you continue to read that, hey, this is actually pretty good. I'm going to keep that. Okay. And then you have quite a few what they call flows. So this is one of the flows. This is another flow. And authentication and session management. Here you go. And then, of course, all of you read about OAuth is about authorization, not logging in. It's about what can you do. The actual authentication or handling identities is done on another spec called OpenID Connect. So the thing is that they are normally used together. So when you do like authenticate using Google, you are using Auth2 in combination with OpenID Connect, but I think everybody else just like you think you're like, oh, I'm using Auth2 for authentication. No, you're not. You're using OpenID Connect, but then Auth2 is part of that workflow for the authorization part. So there's a lot of reading. Look at that. Point being, you have Auth0, you have Okta, you have Firebase Auth, I'm not even going to show you the Microsoft and the Oracle ones. Those are, they don't have like really good starting. I don't even Google Cloud besides Firebase offers another one. But my point is, yeah, go look at Auth0, go look at Okta, go look at Firebase authentication, and use their components and use their libraries and make your life easier. If you still want to handle, let's say, social media authentication and things like that from your Node application and do it manually, you want to look at Passport.js. Probably the number one, I don't know if there's a newer one, but last time I remember, the number one library for handling authentication. And you need two things, right? It's like Connects. You have Connects, and then you need a driver depending on the database. In this case, is you have Passport, and then you have a strategy library depending on what you want to support. So if you want to support Twitter, Google, Facebook, all of those are separate strategy libraries that you combine with Passport to support those. Because if you learn how to do authentication using Twitter and then you go to use authentication using Facebook, you will see that they're not the same. Yeah, so it is not trivial to manually support all of those things. It can be done, but it just takes a lot of work. So Passport.js is where you start. And if you click on the strategies link over here, look at this. They have 502 different strategies with Cacao. So if you want to log in with Cacao, you will use the Cacao Auth2 login module in combination of Passport. For those that do not know, Cacao is a game company as far as I know, because they published the game that I play. If you want to use Neighbor, I don't know what Neighbor is, or I know what Twitch is. Point is, highly likely that whatever authentication strategy or service you want to use, they probably have a library for it, just because they are very popular. So Luis, you spent 2 days talking to me about cookies and tokens and sessions and JSON with tokens and all that, and now you're telling me I shouldn't really implement this by hand? Yes. But if you go use Passport, you're going to understand better when they give you an authenticate middleware. You're like, authenticate middleware. Oh, okay, so they have this middleware that, yeah, okay. And if you go use one of those libraries, when you're reading their documentation, it's going to be a little more familiar to you, the jargon and the terms that they use. you're gonna have a better idea of what's going on. Why am I using a cookie here? Why do I need this token? Why do I read from the URL this token that has to do with the identity, and then I have to make another request somewhere to get the access token? Why don't you just give me the access token right away? So those things are going to start making a little more sense once you have an idea of how it works behind the scenes. They even do taxi services. Wow. Well, I know them because of a game. So what are important pieces of information that you should always encrypt before sending? All of it. Anything that needs to be protected should be encrypted before it's sent to the client, because remember, the client has access to everything. Even if you do a cookie, you say, no, this cookie, is secure, HTTP only, you cannot read it from JavaScript. Yes, but you can always open the tools, look at the cookie, and then just grab the value from there. It's always visible on the client. So anything that you want to protect, you should definitely encrypt it on the server, for sure. Now, that said, though, encryption is not like hashing. Encryption is two ways. That means that someone with a powerful enough computer, quantum computing that we have now, with a powerful enough computer can take that value and hack at it offline until they get it, because they can actually copy the value and have it in the hard drive. So it is different from someone hitting your endpoint, trying to guess passwords. That's different, because they have to hit an endpoint. They have the latency, and you can say, hey, 5 attempts with different passwords for this user ID, I'm going to block that. But whenever you send something to the client that they can grab that and put it offline on their hard drive, I don't trust any of it. So my advice is, yes, encrypt everything, but avoid putting sensitive information ever at the reach of a client. Also, the network. How can you trust the network? You don't go from here to Google, to Gmail, from your house to Gmail. No, you go through a complex layer of servers that are relaying that information from your computer to the servers and then back. If any one of those points is compromised, your data is compromised. So from the point of view of an API safeguarding the data of their clients, you definitely want to be as really paranoid as you can without breaking their experience. Trade-off between security and performance for encryption. No trade-off there. Security first, convenience and performance later. That's an easy one. And if people, just make sure that you explain why your website is requiring you to do something, or why you go that extra step. Just make sure that they understand it's for your security, to keep your data secure. All right, then. See you on Slack. If you follow along, you have the solution for the project in the afternoon. Go practice joins. And notice that we had a join exercise in here. And we felt like, so yeah, practice your database skills. They're going to be very, very important. Now, tomorrow, though, I was telling your TL this morning, if for some reason someone came to me and said, okay, take all of the content that you teach, that Lambda teaches on web, but you can only teach one thing, what would that be? And that would be tomorrow. That's how important tomorrow's lecture is. So rest tonight and be ready tomorrow to be receptive of something that may not feel like useful or important right away. But know that tomorrow's lecture is probably the lecture that is going to give you an extra chance of getting a job on top of other candidates. So be ready and see you tomorrow. Have a good one.